Let's solve a rational inequality where that inequality is already set to 0. So in this case, it is also equal to 0, but we're going to solve the rational inequality 2x plus 3 over x minus 5 is less than or equal to 0. Give our answer in interval notation. Now, you'll notice that we have one side is already set to 0, and that's what we want. So if you happen to have an inequality that has, stuff on both sides, you want to manipulate that to get one side to be 0. Once we are set equal to 0, we are ready to rock and roll. We need to understand our barriers. So our first barrier comes from looking at our denominator. Now, hopefully you recognize that we have a fraction, and having a denominator equal 0 is bad. You cannot have a 0 in the denominator. Therefore, when x equals 5, that will make the denominator equal to 0. That is undefined. So this would be the vertical asymptote of the graph. If we would graph this, it'd be a vertical asymptote. The graph cannot happen at x equals 5, right? So it is undefined at x equals 5. That's one piece. The next piece looks at the numerator. Well, if our numerator equals 0, that gives us an x-intercept. So think about when y is 0, and we try to figure out the x value when y is 0, that's going to tell us the spot on the x-axis. And the reason that's important is because we are comparing to 0. We are comparing to y equals 0, whether we are above or below the x-axis. So if we need to talk about barriers, we're talking about anything that is going to flip the graph across the axis. So in this case, I would subtract 3 and then divide by 2. So at x equals -3/2, that is where our graph is going to cross from either below the x-axis to above or above to below, one or the other. Once we have these two values, we have any undefined issues, right, our asymptotes, and then we also have our intercepts. We are ready to talk about the situations, the different intervals. So think about this as a number line. If this is 0, okay? We don't really want 0 in here, but think about that. So we have -3/2 and we have a +5. This splits our number line up into 3 intervals. We need to figure out what is happening at those 3 intervals. Because remember, we want things that are less than or equal to 0. Meaning we want negative numbers. That is what will make this inequality true. So if we look to the left of -3/2, I'm going to think of what's going to be over there. Well, remember that -3/2 is the same as -1.5. So I am going to try -2. Okay, if x is -2, I'm going to substitute this into our inequality. So 2 times -2 plus 3 all over -2 minus 5. We want to know, does that become less than or equal to 0? Well, in the numerator, -2 times -2 is -4, plus 3 is -1. And then in our denominator, we have -2 minus 5 is -7. That is a +1/7. Is that less than or equal to 0? And that answer is no. So this gives us a positive answer, which makes my inequality false. That is not what we want. So that interval is no good to us. No good. So we go to the next interval. So something between -1/2 and 5. I'm going to try 0 because it's between there. So 2 times 0 plus 3 over 0 minus 5. That gives me 3 over -5. Is that less than or equal to 0? Yes, because it gives us a negative number, right? -3/5. So this is good. We like that middle interval. And then we go to the right. So to the right of 5, I'm going to try 6. So I get 2 times 6 plus 3 over 6 minus 5. I get 15 over 1, which is 15. Is 15 less than or equal to 0? No, because once again, it gives us a positive number. That's not what we want. We want negatives. Therefore, only this piece in the middle works. So we're ready to write our answer in interval notation. Now, pay attention to this because it is very, very important that you understand this part. We're going to start at -3/2. And -3/2 just makes the numerator a 0. That's okay. We're allowed to have a 0 in the numerator. So I'm going to have a bracket because of this equal sign. Remember, we are less than or equal to 0. And my other boundary is 5. Now, if x is 5, my denominator is 0, and we cannot have that. So we're going to have a parenthesis. So with the equal sign in our inequality, we got to think about brackets. But if the value makes the denominator equal to 0, it always has to be a parenthesis because you cannot have a 0 in the denominator. Hopefully, that was helpful with solving a rational inequality.